Hello everyone. From this video, we are going to begin this project more malloc and free. But this video specifically is just an introduction to some functions in which I want to explain. So we've already talked about more about malloc and also free. So today I just want to explain these three functions for us here. This exit function is simply used to cause a normal process termination. Okay, so let me give you an example of it. Let's say let me create file test.c hash include stdio.h. so int main and then void. Right, so let's say I have something like this, and let's say I said printf. So let me just say this is ALX. Okay, so let me just stop it here and say this is ALX. We all know what this is going to do, right? So if I say printf again, if I call printf again and pass in this is ALX software engineering. We all know what this is going to print as well, right? We all know what this is going to print, isn't it? So this is going to print ALX software engineering. Let's compile the program. So gcc test.c-o, let me call it t. So compile, so let's run it. So did you see that we got this is ALX software engineering? So here, if I want to use exit, right, I can pass in exit in a certain position in my code so that from that point onwards the code will not be executed. Okay, so if I should put exit here, if I should say exit and I pass in what? In exit you need to pass in the value. Okay, so it means that when you see a particular value, you'll be able to know what happened. If I should set let's say 20 here, it means that the moment I see 20, I know that this particular part of code has been executed and the statement has reached this exit function. Okay, you can give it any value. Okay, you can give it any value. So just give it a value that when you see that value, you'll be able to know actually what happened. Did the program execute or did it not execute? Okay, so in this case, I'm not expecting this printf software engineering to be executed because from here I'm exited the function. So this exit is going to cause a normal process termination with the exit value of 20. Okay, so let's run this again. Let's compile gcc. Okay, for me to use the exit function, I need to include the library, which is stdlib, right? So hash include stdlib.h. So I think this is a library for the exit function. So let's compile again. So as you can see now, it has been compiled. So let's run the compiled file. So /t. So did you see that I only got this is ALX? It means the remaining part, which is software engineering, is not printed because exit has been encountered. So it is just going to exit the function at that particular point. So that is simply what the exit does. Okay, so and this calloc here is simply used to allocate. Okay, just like malloc, but in this case the calloc here means contiguous allocation while malloc means memory allocation. So what this is going to do is simply this. It is the same thing as malloc. It is the same thing. We know that malloc used something like this. We used to say malloc, right? We used to say malloc and then size of, right, size of whatever, let's say car, right, size of car, and then we pass in what, let's say the size here, right? That's what we need to, we normally do about malloc. But in the case of calloc, all you need to do is this. Calloc takes in what, two parameters. So instead of passing the size of car here, just like this, I will just pass in size of car, and then comma, and then I will pass the size. That's how calloc works. For malloc, it takes in what, one parameter, which is size of whatever times what, times the size or the number of argument, isn't it? But in this case, it is the size separately and also the number of arguments separately. So that's why it's taking two arguments. So this malloc and calloc does the same thing, like I said. So, but what is the difference? Okay, what is the difference? When you allocate memory using malloc, the memory malloc allocates to is going to be a random value. It's going to hold a random value. Okay, while that of calloc, when calloc allocates memory for you, it's going to initialize the memory with the value 0. That's just the difference. That's not only the difference. There are a lot of differences, but that's the main difference in which we'll be focusing for now. Malloc and initialize the memory to allocate to with a random value, while calloc initializes the memory with what, with the value 0. That's just the difference. Okay, all right. So the next thing we need to explain is realloc. So what is this realloc? Realloc is simply used to reallocate memory. So realloc simply means reallocate. So it means that, for instance, if I should use malloc, right, and I pass in, and let's say malloc allocated 20 bytes of memory for me, right, and I store it inside this pointer, let's say ptr is equals to this, right. So now this 20 byte memory is not enough for me. I want to add it. I want malloc to increase the memory for me. So I can simply say realloc. I can simply call realloc, which means reallocate, and then I will pass in the pointer that holds the initial call to malloc, which is ptr, right? So ptr here is holding the what? The memory in which I want to resize. So I'll just say ptr, and then here I will now pass, let's say I want to make it 30 instead of 20, so I'll just pass in what? 30 here. So I've reallocated the memory. So ptr now is going to have 30 bytes. If I want to reduce it, I can make it 10 here. So ptr is going to be resized to what? To 10 bytes. That's just what reallocate does. Okay, so please just read more about it. I'm just trying to give you an overview of what these functions does. Okay, so that's all I want to explain about this. So in the next video, I'm going to begin solving tasks of this project. So thank you very much. Till we meet in our next session.